All right, 4.2, the mean value theorem. And it starts off with rows. Uh, all right, Rolle's theorem states that suppose that y is equal to f of x is continuous, or y equal to f of x is continuous over the closed interval AB and differentiable at every point of its interior AB. If f of a is equal to f of b, in other words, when you plug in a to the function is equal to when you plug in b into the function, then there is at least one number c in that interval of AB at which f prime of c is equal to 0. All right, and that goes back to what we talked about last class. This means it's a critical value. We talked about f prime of x being equal to 0. All right. This is just a statement backing up what we talked about last class. And this is just, like I said, just reiterating what we talked about last class, being continuous. F assumes absolute maximums and minimums, absolute maximum, absolute minimum values on A, the closed interval AB. These can only occur at interior points when F prime is equal to 0, at interior points where F prime does not exist, and at the endpoints of the functions domain, in this case, A and B. All right. As a matter of fact, let me draw this diagram. All right, so this is just a generic example or graph to illustrate what we mean by having these max and mins at these critical points where f prime is equal to 0 or is undefined. So we have these absolute max and mins or relative max and mins. Where it could be at, depending on what the interval is. And so at these points, these peaks and valleys is where f prime would be equal to 0. No, no. All right, so we want to show that the equation x squared plus 3x plus 1 equal to 0 has exactly one real solution. Let me see, did they give us an interval? Hold on 1 second. Let's see my interval. All right, so let's go here. All right, I'll just do with this. I'll start with this. Okay, since when you plug in -1 into the function, let's go ahead and do that.
Isn't it supposed to be squared? Not.
Yep. Thank you very much. One. That should be -1 there. All right. Thank you. Okay. So actually, it is cubed. So I messed up initially. So the problem we're looking at is a 3. All right. So it should be x cubed plus 3x plus 1. The reason why I messed up initially, the reason why I was pausing because I didn't see my interval. I thought they gave me an interval with this problem, but they didn't. So we're going with this, and I'll tell you why in a second. So let's look at -1 and plug in 0. All right. So the intermediate value theorem tells us that the graph of f crosses the x-axis somewhere in the open interval of -1, 0. So in other words, when you look at the intermediate value theorem, when you look at the fact that I have a negative 3 here when I plug in -1, then I also get a positive 1 here. So in order for me to go from negative to positive or positive to negative, I had to cross 0. And 0 is that x-axis. So that's what we're talking about, intermediate value theorem. There is a value in between these 2 points. They had to cross the x-axis at some point. In other words, that would be a solution. Oh, not x equal to 0, sorry, y equal to 0. All right, so we're talking about crossing the axis, or probably should say x-axis. Crossing the x-axis, that means y is equal to 0. Also, that means there's a solution for f, which is f of x equal to 0. So we know that there's one solution there, according to the intermediate value theorem. And we want to show that the equation has exactly one real solution. So we know that there's one there. So what is it that will stop us from having more than one? Let's see. So now looking at Rolle's theorem, we would take f prime and analyze that. So it was x cubed, so that means the first term would be 3x squared and 3x, so it's plus 3, and then 1 will go to 0. All right, so looking at Rolle's theorem, which is what we mentioned beginning of this section, we look at f prime of x, that's going to be 3x squared plus 3. It will never be 0 or undefined. The x squared prevents a negative value. So the only way you could get one is if it's imaginary. And remember, we were looking for, real solutions. So you're looking at both of those theorems, the intermediate value theorem, which lets us know we have at least, we have that one solution. And here, Rolle's theorem doesn't give room for anything else to occur.
I have a question.
Yep.
what is it about uh, finding the derivative of that equation that tells us that it won't cross that? Like what? I don't know how to word that question. I think you get where I'm getting at.
Yeah, so you're talking about basically why,
Like why does that work?
yeah. Um, I think you're going into background information that um the people that, back in the day did to validate this, and I believe they have it in the book. I'll have to look at the first example. I don't have it up, but yeah, if I'm not mistaken, there is a proof, and I'm not mistaken. There's always a proof for all of these theorems. So the idea of why, then you have to go through that proof in order to, see the why. Um, I would have to look up the actual proof because that's background information. So what I can do is see if it's something that we want to talk about. But as of right now, when you talk about these theorems, when they say, okay, this is this, then most of the time you say, okay. Not
Yeah,
trying to be funny.
just take it for how it is. Yeah.
Yeah, yeah, not trying to be funny. Sometimes the why is so involved, it's just like, okay, well, yeah, thanks. Like, you know what I mean? I'm not, I'm not trying to be funny. But that's, I know when I was doing it, learning it, that's pretty much how a lot of people were just doing it. It was like, look, man, you probably don't really want to know the why, but if you can learn how to use what we've given you, basically it's like, okay, they give you a hammer and say you hit this with a nail, and then you're saying, well, how did you make the hammer? You see what I mean? So
Yeah, yeah, yeah.
yeah, yeah. So I'll check it out, and if it's not too involved, we can go. We can talk about it. I don't have a problem doing that. I don't have I don't have the book up right now. I just have screenshots of certain things that we were going to talk about. But next class, I will look at that. Next class, I will look. By next class, I would have looked at it and see if we want to go into it deeper. Yeah, that's a good question, though. All right, let's go to the next theorem. All right, the mean value theorem. Suppose y is equal to f of x. Y equal to f of x is continuous over a closed interval and differentiable on the interval's interior. Let's spell interval right. Interval's interior, AB. Then there is at least one point C in AB at which f of b minus f of a over b minus a is equal to f prime of c. All right. So we'll do problems, a few problems to prove this. And the application, let's see. Guess we'll use application a little later as far as the examples are concerned. Okay, we're just setting the foundation. All right. We'll do a few of these problems and then we should be good to go. All right. Also in this, let's suppose that it is continuous over the closed interval and differentiable on the interval's interior. So that's key in the characteristic of f of x. It has to be continuous over the closed interval and differentiable on the interval's interior in order for this relationship to hold true.
What do you mean by differentiable?
When you find the derivative of it, you find the derivative of the function. If you plug in a value, let's say if just a loose example, if f prime was 1 over x minus 5, but the interval that we're looking for or that we're using is 1 to 7. Well, it's not differentiable at 5. You know, if I were to plug in 5 into f prime, because when I plug in 5, it's undefined because I get 0 in my denominator.
Okay, yeah, that makes sense.
All right, cool. All right. All right, so the directions find the value or values of C that satisfy f of b minus f of a over b minus a equal to f prime of C. I ran out of room over there. In the conclusion of the mean value theorem for the following function and interval. So the problem we get should be giving us intervals to do our examination on. All right. So, oh, get my pen back. So normally A is the first, B is the second in our interval. So when we're looking at f of A, let's plug it in -3. That's so it's 2 times 9 plus 15 minus 3. 18 plus 15 minus 3. Add those together. Should get 30. All right, plug in B, which is 0 for us. All right, 0 minus 0 minus 3 is -3. All right, any questions so far? Should be good with that. That's just plugging in values. All right, so let's find F prime. So that was, I can do it from here, 2x squared. So do this. All right, so find the derivative of f, talking about f prime. So you bring down 2, that'll be 2 times 2, which is x, and then minus 5. So just getting all of our pieces together. All right. So we go back to B. F of B is equal to -3. F of A is equal to 30. And then we had what, -3 and 0. So 0 minus -3. So this is F of B, F of A, B and A. -33 over +3 is -11. And then here, F prime of C is just plugging in C into the function. And remember what the mean value theorem said. It says F of B minus F of A over B minus A is equal to F prime of C. So that means F prime of C is equal to -11, which means it's also equal to 4C minus 5. So I can set both of those pieces equal to each other to figure out what C would be. questions before we finish it off? All right. Add 5 to both sides. 4c is equal to -6. Divide by 4. C is equal to -6/4, which means C is 3/2, -3/2. All right, questions before we do another one?
So what is C? What did we just figure out?
So C is going to be the place where there should be, and going back here, F prime of C, trying to relate it back to our, that's when F prime of C is equal to 0. It should be a critical point for us. I'm trying to just relate it back to our theorems.
So C is the minimum or the maximum of that graph of the original equation.
Yeah, I was trying to actually find one that actually points right to it. Because here, when we go back, we're talking about F prime C being equal to 0. But I was trying to point, when we look at our mean value theorem, suppose closed interval differential, then there is at least one point C at which F prime C is equal to that. Yeah, it's going to be a critical value for us. The application of it, though, I think it comes in the next section where we start actually using this information to create graphs. Because what we're going to do is we're going to figure out these theorems. Do these theorems, and they have like 3 or 4 different theorems in which we will be able to use all this information to actually do graph sketching or rough sketches of our graphs. So instead of actually depending on the graphing calculator, according to all of these calculus theorems and happenings or whatever, you'll be able to, it's called curve sketching, and you'll be able to graph the curve yourself. You'll be able to know, according to the derivative, when it's concave up versus concave down, when it's increasing versus decreasing, and when it goes back to increasing again, and different things like that. And all of those things are based on critical points and things of that nature. So all of this will come together when we actually get there and have all of them at our arsenal. All right, let's do another one. All right, same directions. If f of x is equal to 5x plus 5 over x, but this time our interval is from 1/4 to 4. So we do our plugins, and we're looking at this being A, this being B. And going back to what we were saying too, we're going to be able to use this as well when we set the stuff equal to 0. Yeah. Okay. But yeah, a lot of stuff gonna come up as we progress forward. Y'all just something that just hit me. So I won't go there right now. But a lot of stuff will come up as we progress forward. So as to why and all the good stuff like that. All right. So don't forget your fraction work. That's 5 divided by 1/4, and multiply by 4/1. That'll give you 20. You need a common denominator and all the good stuff like that. Multiply top and bottom by 5. Nope, by 4. Excuse me. So 5/4, 80/4, 85/4, so 85/4. All right. Now plug in 4. We'll do the same thing. 5 times 4 plus 5/4. Look like we're going to get the same thing. So it'll be 20. Now I'll bring it down here. 20 plus 5/4. Multiply top and bottom by 4. That's 80/4 plus 5/4. 85/4. All right. So f of b minus f of a over b minus a. F of 4 minus f of 1/4. 4 minus 1/4. It's 85/4 minus 85/4. 4 minus 1/4. And that denominator doesn't matter because I have 0 in my numerator. So that means that is 0. And that is, as a matter of fact, I'll leave it like that. And then go here. All right, so we know f prime of c is equal to 0. Now we need to look at f prime, not f prime, f of x, which was 5x plus 5 over x, which can also be written as 5x plus 5x to the negative first power. And I want to find f prime. So derivative of 5x is just 5. Then derivative of 5x to the negative first, you bring down negative 1. Subtract 1 from negative 1, which would be negative 2. So that's 5 plus, not plus, 5 minus 5 over x squared. Five minus 5 over x squared, c squared. And I probably should have used my blue here if I was staying consistent. That's all good. So now we have our two pieces, and we most definitely can see our relationship here to critical values. F of c is equal to 0. So that means five minus 5 c squared is equal to 0. And to solve for c, multiply the whole thing by c squared. So if I multiply each piece by c squared, that would be 5c squared minus 5 equal to 0. This one down bottom will cancel. All right, subtract 5, add 5 to both sides. 5c squared is equal to 5. Divide by 5. C squared is equal to 1. Square root. C is equal to plus or minus square root of 1. Don't forget, whenever you take the square root of both sides, you have to do plus or minus. So the plus or minus 1. And that's what we have here. Also, make sure each C is in the interval. Because if they're not in the interval, then we can't use them. So our interval is 1/4, 4. So we're going from 1/4 to 4. So the only value that we can use, I'll just say we can use so the only value we can use is that c equal to 1 in this case because of the intervals that they gave us. And like I said, most definitely in this one, we should be able to see that connection to our critical values of the theorem stated before, because F prime C ended up being 0. And so that was one of our main focuses. All right. Questions on anything that I've said up to this point?
No, sir. It makes sense.
All right, cool, cool. And like I said, this is just the beginning of us setting the foundation. All of this will come together when we add a few more things. And so if you're good, I'm good. Next class, we will look to add more to the puzzle. All right, man. You have a good weekend and be safe.
Yeah, you too. And I'll make sure to get that test done tomorrow.
All right, sounds good. All right, take care, man.